Thank you, everyone, for coming to this talk. I know it's hard to choose between talks. My talk for today is trying to demystify the ahead-of-time compilation in Angular. So the purpose of this talk is to try and help you understand how the compilation in Angular works. Like there's mainly two compilation processes in Angular, like the JIT compilation and AOT. And I hope at the end of the talk you will leave the talk with some tips and tricks on how to make your app statically analyzable by the compiler. So obviously making the compiler happy. But before, let me just tell you a little story. During last December, Igor Minard from the Angular core team was in Paris. And he was for the .js conference, which was in Paris. And the day after the conference, I spent the whole day with him meeting some French companies, from the Fortune 500 list, who are using Angular and who want to give some feedback about it. And then one developer asked a question to Igor, okay, so I have this issue with the AOT flag in the CLI, which giving me troubles. And then Igor started to explain to him, drawing how the template compiler works and all the stuff. And then I said, okay, probably might need to give a talk about this subject. So if this guy asked this question, so probably many other people are asking the same questions or having issues trying to get their application compiled with AOT for better performance. So my name is Wassim Chegham. I work for a company called Sphere as a developer advocate in Paris, in France. You can follow me on Twitter, my nick Ineko, and also on GitHub. Or if probably some of you have already received the notification, which is part of the physical web. And also I'm part of the GDE program run by Google. So let's first talk about compiler before we dive deep into AOT versus JIT, whatever. So for this, I'll try to give a much detailed explanation of how compilers work. We'll start from the top of this diagram. Okay, I'm just kidding. We're trying to demystify, not mystify. Okay, so sorry about that. It was a joke. So we're going to keep things simpler. So just ask Wikipedia, what is a compiler? So if you ask this question on Wikipedia, okay, a compiler is a program that obviously transforms some sort of code source written in any language into, usually into a computer language, machine code language. So what does this mean in Angular world? So in Angular, where I'm going to talk about compiler, or when you read in the docs or somewhere else the compiler in the Angular context, we're talking about the template compiler. The template compiler is this code that transforms your HTML code into JavaScript. We'll explain this later. So yeah, obviously when you write your templates, it's HTML most of the time, unless you are doing JSX or something similar. So then everything between your source code and your running application, the template source code and your running application is transformed and compiled by the Angular compiler, which holds many internal logic like parsers, which transform your HTML into tokens and lexers and all this stuff. So for this talk, we are going to focus on JIT and AOT, which, by the way, you can find other languages like Java or C or C++. This is nothing new in Angular. So what is JIT? In computer science, JIT, just-in-time compilation, which is also obviously known as a dynamic translation. It's a compilation process which happens during the runtime of your app. So I guess most of the current or maybe past JVMs were JIT. Who is Java developer in the audience? Can you confirm this? Yeah? Okay, nice. I'm not Java developer. So. You can see this on the latest Android, when they switch from JIT to AOT, and your startup time took too much time to optimize the application. That's because they switched from, I don't remember, JIT to AOT or AOT to JIT. So anyway, so in Angular, when you take its source code, run it into the compiler, transform all this source code, mainly, let's say, the HTML, because we are talking about the complete compiler. And then this compiler generates code, which then gets run by the V8 machine, like Chrome, or the JavaScript engine in general. So in JIT mode, obviously you have your source code on your server. So this is on build time. You have all your assets, all the source code that you run through the bundler, and everything gets sent to the browser. So the browser here, it's the runtime. So your application running obviously on the browser. Not mentioned in Universal here. So everything gets compiled, run, transformed on the browser at runtime. So this we call dynamic. Of course, there are some drawbacks with this compilation process. Some of the drawbacks are the bundle size, because you are shipping all the compiler, all the parser, the lexers with your application. Of course, because you need it at runtime. Otherwise, your application won't work. Some performance issues, because you are compiling at runtime. So this takes some CPU cycles, probably lots of memory. It's also because your bundle size is bigger. Usually it's bigger, so it takes some time to bootstrap your application. From when the browser receives all the assets, all the JavaScript code, until the first interaction, the first paint. And lastly, probably some security issues, because we'll talk about this later, actually. This is more interesting in this is something that AOT solves, or tries to solve. So of course, maybe ahead of time compilation can help. Let's see why. So before, let's get a definition from our friend Wikipedia. So ahead of time compilation is trying to transform your source code, your high-level programming source code, into a native language. Usually for other languages, that would be bytecode for Java, or ASM, or I don't know, for other low-level languages. So in the context of Angular, again, the source code that it generated is a VM-friendly, V8 VM-friendly code. It's a code optimized for V8. So if you take the same diagram as before, as for JIT, so for AOT, we start from the same HTML code, which gets compiled this time by the AOT compiler. We also, of course, have the same code that it generated by this compiler. And at the end, we have the same JavaScript V8 friendly code. But the difference here is all the first steps are happening on the server during build time. This means that you take your application and you compile it during your the build time, usually. And then you just have let's say, one JavaScript file that you send to the browser, which gets executed by the browser. So we call this static compilation, like in computer science. But in order to allow the compiler, the template compiler, to compile your code, your application, this compiler needs some context. And this context in Angular comes from the ng modules, like in general. So are you familiar with modules? I hope so. Okay. So when you write your modules, you give some metadata using this annotation, ng module annotation, and then you reference all the providers, all the components, everything that is used inside one module. And of course, you compose your modules to form a bigger application. So in JIT mode, you typically use this approach, which is, by the way, this is what gets generated by the Angular CLI. Who's using the Angular CLI in the audience? No, not that much. Okay. 20%. So in JIT mode, you require the platform browser dynamic. Anyone knows why we have the dynamic word in this function? Simple question. Because of JIT, yes, because of the JIT, so we are requiring the dynamic compiler, like version of the compiler. And then we import our main app module and just bootstrap the app. For AOT, things are like a little bit different. This time you require the platform browser, obviously static one. And then you import something we call the factory module. So this code we'll see just on the next slide. This is what gets generated by the AOT compiler during the build time. Actually, this is the same code that gets generated during runtime in the JIT mode on the browser. Just now we're generating the same code on the server. And then you bootstrap your app using the platform browser. If you want to try right now this approach, just install those dependencies if you are not using the Angular CLI. The Angular compiler -CLI gives you this ngC binary, which lives inside your node modules. So you run it and you give it the test TypeScript configuration file, and then it will generate, if things goes like right, you will have all the compiled code generated in your folder. Well, this depends also on which configuration you are giving it. So the screenshot behind is the sample code of what gets generated. So this is not meant for you or for us, human, to read, even if it's human readable code. But this is like really optimized for JavaScript engines. And of course, you can use this. By the way, the code behind is the TypeScript code. TypeScript, everyone knows what is TypeScript? Okay. So this is TypeScript. So what you can do is, like the good thing you can do with TypeScript, because it has types and everything, you can run it through some sort of tree shaking tool, like Rollup or probably Webpack. Tree shaking is the process of removing all the parts that are not used inside your application. For instance, if you are if you are not using, let's say, the ng4 directive, so the tree shaking program will remove the code of ng4 from your app. It will not ship with your app. By the way, tree shaking is different from dead code elimination, because dead code elimination goes really into details instructions. For instance, if you have an if-else statement, if your code never goes into the else, which might be weird, the program might remove this part. The good news is because out of this, you have like X% less code. So this is these numbers are not like scientifically proven numbers that are just like the results of some experimentations I did. So this might depend, of course, on the how big is your app. Maybe probably it could be more less code because the compiler needs to generate optimized code. So if you have really complex app, I don't know what the compiler would generate. But during my exercise, I ran it through the Hello World app that get generated by the CLI, like the AppWorks app. Run it through the Source Map Explorer program, which gives you this overview, this high-level image of your used modules and dependencies. And you can see that the compiler takes 45% of the generated source code. But in AOT, because we don't need the compiler anymore, so we don't have it into the source code. Into the generated code. And of course, if you run your generated code through a tree shaker program or like dead elimination code, I believe you could have like less and less code. So this slide was from Tobias, who is on the Angular team, who is like the genius behind the compiler, the template compiler. So this slide was from Angular, last Angular Connect. And you can see that you can have real benefits using your AOT compilation process. I have nothing to say more about this. So, because we have no more dynamic template compilation running under browser, so we have less security risk. Why? Because we are not evaluating the code, the source code anymore. Yeah, I have some screenshot about this because this evil, as anyone knows. So yeah, we're trying to avoid really evaluating code that comes from outside Angular. Thankfully, we have like mechanism like trust HTML, I guess, or some sort of mechanism. Of course, because we have less code to execute and less code to load to the browser, we then have faster TTI, which is time to interaction or interactive. Can't remember. So if you use Chrome, the DevTool, and try to analyze what's happening in the timeline, okay, you can see some really big difference with the same app compiled using JIT and the same app compiled using AOT. Obviously, in AOT, the TTI is really small. It's smaller, like maybe 50% smaller, probably. So we really have like big interesting benefits. I don't know if it would be the same results if the app was really complex app. I'm really not sure about this. Anyway, so the good news is AOT works today, so you can use it. If you are using the CLI, and probably you should use the CLI if you have like choice. I'm saying this because some customers don't have the choice, so they can't use the CLI because they have some internal tools. So I completely understand. But anyway, with this CLI, just build your app using dash, probably I guess one dash, it's enough, dash AOT. And also you can add dash prod if you want to mangle your application and have like a smaller bundle size. Or if you are just using Webpack, you could take advantage of the Webpack plugin that the team has built for this purpose. By the way, the Angular CLI uses the same plugin. So yeah, just require the plugin and drop it inside your Webpack configuration. Some bonus. Okay, 10 minutes. Getting your app run through the AOT compiler is not easy because you need to, like, for the moment at least, you need to have a AOT-friendly code. So during my, like, the work I've done when I prepared this talk, I tried to write down all the errors I got so I can share them with you. So next time when you see the error, you know where it comes from. So for instance, so I only have 3 errors. Don't freak out. So for instance, if you see this error, the AOT compiler complaining about some, I don't know, then couldn't resolve symbols statically, blah, blah, blah. So this is because you are using, probably in your, so this code comes from, let's say, a module. So inside your module, probably you are using a function. So this is the right approach. So inside the use factory, usually you are using the lambda function. Okay, we all agree. Usually, okay. So instead of doing this, you should do this new approach. Export the function and then use the reference inside. But this is really an example of if you are using any, if you are calling any lambda expression inside your module, whether for, let's say, maybe for trying to configure a router, or maybe like just creating a small helper function that returns a table of, an array of providers, this won't work. You need to create and export that function and then use it as a reference. Does it make sense for everyone? No?
Why do you need to export?
Because you have to do the export for the compiler. I guess when the compiler requires your code, it needs to require this function. That's my explanation, at least. No. Sorry? No, at least at the app module level, inside the app module. That was what I discovered. Next error is related to access modifiers. So, for instance, in your component, if you used to have private properties, maybe some of them will crash because of this error, so you need to make them public. Don't yell at me. It's not my fault. This is what I discovered while running through this talk. And then, who's doing this kind of approach, the bad one? No? Okay. Me neither. Okay. So you probably are going to run this through this error because you have to export the not named symbols. But this is what for instance, the Angular CLI generates, and all the docs are referencing the good approach. So yeah, that was 3 questions. If you know or find more, please tweet them to me so I can probably add them to the slides and of course mention your name and yeah, share it with the community. That was it for me. So just before I end my talk, I have prepared. Okay. Yes. I have prepared this app that I'm using for another project. So this app is this is a sample app taken from a real existing app we used internally. On the left side, I have a JIT compiled version of the application. And of course, on the right side, I have the AOT version. Okay, as you can see, the TTI is around, I don't know, maybe, where is it? Okay, I lost the cursor. Anyway, you can see roughly that it's around 1 second. Like the runtime compiler, the JIT compiler, taking more time to eval the code and execute it. Sorry. Just watch this here. We are around maybe 700 milliseconds. Compared to here, we are around 1 second. And of course, if you're stats underneath it, it takes small time to run to load the code, to run it, to execute it. And again, this is really simple application. I would love to hear from you guys some real world stats. So if you can share them on Twitter, probably some screenshots or any GitHub repo, if it's a public app, of course. So yeah, that was all for me. So thank you.